In this video, I'll be showing how to solve rational equations. So these are each examples of rational equations. Note that a rational equation always has at least one rational expression. So a rational expression is where we have a polynomial in the denominator of a fraction. And a polynomial is an expression that has a variable in it. That's a very simplified way of thinking about it. So if we ever have a variable in a denominator inside of an equation, we have a rational equation. So in this video, we're going to be talking about how to solve these types of equations. So let's look at a simple example first. If I have 1 over x plus 1/3 is equal to 5/6. Now what we want to do is solve for x. Now to do that, what we want to do first is figure out what the least common denominator is of each of these fractions. So the least common denominator here is going to be 6x. Okay, so what we do is we multiply each term by the least common denominator. Okay, and what's going to happen is the denominator is going to cancel with some part or all of that least common denominator. So in the first fraction, the x's cancel, so I get 6 times 1, which is 6. In the second fraction, the 3 and the 6 get reduced to a 2x. So 1 times 2x is 2x. And then the 6's cancel on the right-hand side, so we get 5x. Okay, so now we have a pretty straightforward linear equation. We're going to have 6 is equal to 3x, divide both sides by 3, we get x is equal to 2. And then the final step is to check to see if this solution makes any of the denominators equal to 0. And the only place that we have an x is in the first fraction on the left, but we can plug in 2 there and we'll get 2 as the denominator. So this does check. And we'll see an example or two where the solution does not check. So the rest of this video will just be going through a few kind of increasingly complicated examples. So the first one, we have 1 plus 5 over y is equal to negative 6 over y squared. The least common denominator here is going to be y squared. This 1 is over 1. Okay, so what we're going to do is multiply each term by y squared. Oops, let's multiply that negative also. Okay, so on the left, y squared times 1 is y squared. 5 over y times y squared, well, one of those y's is going to cancel, so I'm left with 5y, and then the y squareds cancel here. So this is a quadratic equation. When we have a quadratic equation, we want to set this equal to 0. Plus 6 is equal to 0. And then we're going to factor this. So y plus 3, y plus 2 is equal to 0. So I get y is equal to negative 3, y is equal to negative 2. And then we need to check to see if we end up with any erroneous solutions, if we end up with any solutions that have a 0 in the denominator. Well, I just have y and y squared. If I plug in negative 3 or negative 2 in there, I'm not going to end up with a 0, so this does in fact check. Alright, and then let's look at the next one. We have 12 over x squared plus 4 over x is equal to 1. This one's pretty similar to the last one. The least common denominator here is going to be x squared. So I'm not going to write everything out, but we multiply each term by x squared. In that first fraction, 12 over x squared times x squared, the x squareds will cancel. We'll just end up with 12. In the second fraction, 4 over x times x squared, well, one of the x's will cancel. I'll end up with 4x. And then on the right-hand side, 1 times x squared is x squared. This is a quadratic again, so I'm going to set this equal to 0. I'm going to factor this to x minus 6, x plus 2. So we end up with x is equal to 6, x is equal to negative 2. And again, neither of these are going to cause a 0 in any of the denominators. So those both check. This one is a little bit more involved. So one thing we'll want to do is if we can ever factor a denominator, we're going to want to go ahead and do that. So I can't factor y plus 6 on the left-hand side, but y squared minus 36, that's y plus 6, y minus 6, plus 4. So the least common denominator here is going to be y plus 6, y minus 6. So I'm going to multiply each term by y plus 6, y minus 6. The fraction on the left, the y plus 6's will cancel, so I'm left with y minus 6. Sorry, that's not correct. What I mean to write is, so I'll just write it out. Y plus 6, y minus 6 here. So the y plus 6's are going to cancel, so I'm left with y times y minus 6. That's what I meant to write. This first fraction on the right-hand side, well, the y plus 6, y minus 6 will cancel with the least common denominator, so I'm just left with 7. And then 4 times, nothing is going to cancel, so I have this. Okay, so this is now just a pretty straightforward equation that I'm going to go ahead and simplify everything and then see what type of fraction, or I'm sorry, see what type of equation we have. So 7 plus, this is going to come out to y squared minus 36 when I multiply it all out. So 7 plus 4y squared minus 36 times 4 is 144. Okay, so there we are. This looks like a quadratic because I have y squared. I'm going to write everything on the right-hand side. So 3y squared plus 6y, and then 7 and negative 144. Something's wrong here. Geez, I made a simple mistake. I went from 72 to 7. So that 7 should actually be a 72. Okay, so 72 and negative 144 is going to be negative 72. Okay, so let's see if we can factor this. Well, first off, I think I have a common factor of 3. So y squared plus 2y minus, what do we have? Is that 24, I think? Yeah, 24, okay. And then we can factor that. So 0 is equal to 3. Y, let's see, plus 6 minus 4. Okay, that's what we get. So y is going to be equal to negative 6, y is going to be equal to positive 4. And then we need to check to see if any of those values make a denominator equal to 0. If I look back up in the very first equation, if we plug in negative 6 right here, that's going to make a 0 in the denominator. Similar, if I plug it into this fraction, it also makes the denominator 0. So negative 6 is not a solution. So y is equal to 4 is our only solution here. Alright, the next example, we have m plus 11 over m squared minus 5m plus 4 is equal to 5 over m minus 4 minus 3 over m minus 1. So if we were to factor this denominator on the left, we're going to have m minus 4, m minus 1. So that's convenient, that the least common denominator is going to be m minus 4, m minus 1. Okay, so on the left-hand side, I'm going to multiply by the least common denominator, and the denominator will cancel, so I'm just left with m plus 11. On the right-hand side, the m minus 4's will cancel, I'm left with m minus 1, and then 3 times m minus 4 here. Okay, so let's go ahead and solve this. M plus 11 is equal to 5m minus 5 minus 3m plus 12. We get 2m plus 7 on the right-hand side. So I'm left with m is equal to positive 4. Now, if I plug in 4 right here, that is not going to check. So, in fact, we would say that there is no solution to this equation. So let's look at the graph of this. So what I did was the left-hand side of that equation, I graphed right here, y is equal to the left-hand side, and then I did y is equal to the right-hand side. So the left-hand side was in red, and the right-hand side was in blue. And what we'll see here is that the right-hand side and the left-hand side, they get really close to each other, but they never touch. So because the curves never intersect, that corresponds with there being no solution. So we can solve an equation like this, any equation, if we have the left-hand side, if we graph that, and then we also graph the right-hand side, wherever the curves intersect, that tells us where the solution to the equation. And if there's no intersection, that means there's no solution. Alright, and then the last examples we'll see is how we can solve different equations for specified variables. So the first one we have we have m is equal to y over 2, y minus 2 over x minus 3. We want to solve for y. So what I'm going to do is I'm going to multiply both sides by the denominator here, or in other words, we want to cross multiply. When we distribute, this is what we get. So to solve for y, I'm just going to add 2 to both sides. mx minus 3m plus 2 is equal to y. So that one's pretty straightforward. For the second one here, solve 1 over c plus 1 over m is equal to 1. And we want to solve this for c. So what we want to do is figure out what the least common denominator is. The least common denominator is going to be cm. So multiply each term by cm. So on the right-hand side, we'll end up with cm. On the left-hand side, I get cm times 1 over c. Well, that's just m. 1 over m times cm is just c. Okay? So when we want to solve for c, and it appears in 2 terms, we want to collect those terms on the same side of the equation. Then we're going to factor it out. Okay? So by factoring out, that allows us to divide to isolate c. So c is equal to m over m minus 1.